Question number 2. In the figure below, inscribed triangle ABC is equilateral. If the radius of the circle is r, then the length of arc AXB is which of the following? So we have to find the length of arc AXB, that is this length we have to find. Before we find the solution of this question, let us discuss the inscribed and the central angle. Here is another figure where we are going to discuss what is inscribed. An inscribed angle is an angle whose vertex is on a circle and whose sides are determined by two chords. So this one is one of the chord and the other chord is this, and the point is on the circle. So this angle is an inscribed angle which I am pointing it. So this is the inscribed angle. It doesn't matter if it is here or if I move it, as long as the point is on the circle. This is an inscribed angle. Now the central angle is an angle whose vertex is at the center of the circle and whose sides are determined by the radius. So this is one of the radius, AO and CO, they are the two radius. So this angle is the central angle. The theorem says the measure of an inscribed angle, which is vertex is on the circle, is 1/2 the measure of its central angle, or it is also called its intercepted arc. So whatever the angle we have here, the inscribed angle is going to be half of the central angle. So let us see some example. Here is the examples. Now right now I can move it, and let us say it is 116 degree is the central angle. Half of it is 58 degrees is going to be the inscribed angle. It does not matter if I move the inscribed angle anywhere, as long as it is the inscribed angle is going to be half of the central angle. The position doesn't make any difference. Even if I rotate this, if the circle is like this, even then the inscribed angle is going to be half of the central angle. So that is one thing. So if I move it, let us say 126.4, then it is 63.2. Once we have the central angle, inscribed angle can have any position. It doesn't matter. It is going to be half of the central angle. So if we know the central angle, we can find the inscribed angle, or if we know the inscribed angle, we can find the central angle. Now, what happens if the central angle is 180 degree like this one? So now in this case, actually this is the central angle is 180, so the inscribed angle, which is 90 degree. That means that even if I move this anywhere, this triangle or right triangle I move, the vertex inscribed angle, it is going to be a 90 degree, which means that if you have a triangle inscribed in a semicircle, then that triangle will always be a right triangle, which you can see. It is always going to be a right triangle if its hypotenuse is formed by the diameter of the circle. So it doesn't matter if you move it anywhere, any position, like if you do that way, and if it is a semicircle, you can see it is going to be 90 degree. It is a very important information. One should remember that a triangle inscribed in a semicircle is always a 90 degree. It is a right triangle. Lot of questions in SAT they ask where this information is a useful information for the students to know. So inscribed angle and a central angle, we are further going to discuss this concept in another location. And when we discuss the geometry section, we are going to discuss this in detail about this, how it is twice the central angle is, how it is twice the inscribed angle, and all those kind of things. Right now this is good enough to know that the central angle is twice the inscribed angle, or the inscribed angle is half of the central angle. Let us go back to the question. Now here is the question. This question, we have to find the arc length. So if we are going to draw the radius, so let us draw the radius. Here is the, you can see it is an equilateral triangle, so all the angles are 60 degree. So this inscribed angle, which is at point C, it is 60 degree. It means the central angle, which is this one, obviously it is going to be twice the inscribed angle, which is 120 degrees. So if this is 120, the arc length, intercepted arc length, is also going to be 120 degrees, which is 1/3 of the length of the circumference of the whole circle. What I mean is this: if I'm going to say that if this angle around the center, this covers 360 degrees, then the entire circumference of the circle is going to be covered by this 360 degree. But we are only interested to know the arc length, which is covered by 120 degrees. So 120 is 1/3, 120 degree is 1/3 of 360. So the arc length is also going to be 1/3 of the circumference of the circle. The circumference of the circle of radius r, then C is equal to 2 pi r. That is the length of the circumference. But we are not looking for the entire circumference. We are only looking 1/3 of it, because 120 is 1/3 of 360. So we just have to divide this by 3. So the answer is going to be A. I hope you understand the question and its explanation. Let me try to show you one more time this question. I'm going to reset, watch the video. These are the equilateral triangles, so 60 degree. This is the radius r and r. This is the arc length we are going to find. Then the central angle is going to be 120, because this is 60. So the central angle is going to be twice of the inscribed angle. So this is 120, and 120 is 1/3 of 360. So the arc of the arc length is going to be 1/3 of the circumference, which is 2 pi r divided by 3.